Hello everyone, this is Lalitha, Assistant Professor Electrical and Electronics Engineering Department. The today topic is Multiplexer. Multiplexer is shortly called as a MUX. A MUX is a digital switch that has multiple input and a single output. The selection lines determine which input is connected to the output. So the input is 2 power n, the output is 1, the selection line is n. In the 2 power n, the selection line is considered as an n. So based on the 2 power n, the types of multiplexers are 2:1, 4:1, 8:1, 16:1 likewise. In 2:1 we have the one selection line because it's 2 power 1. In 4:1 it's 2 power 2, so 2 selection lines. In 8:1, 3 selection line. In 16:1, 4 selection lines. A multiplexer is a device that allows digital information from several sources to be routed onto a single line for transmission over that line to a common destination. The basic multiplexer has several data input lines and a single output line. It also has data select inputs which permits digital data on any one of the inputs to be switched to the output line. The application of a multiplexer is we can play the song in the sound system through our MP3 player, laptop, digital satellite and digital cable TV. So here we have the many inputs and the output is 1. We have the selection lines in between the input and output. The selection lines, based on the selection line, the input is connected to the output. If it is the input is 0, 0, the MP3 is connected to sound system. If it is 0, 1, the laptop is connected. If it is 1, 0, the satellite is connected. If it is 1, 1, the fourth input is connected to the output. This is the functional diagram of multiplexer. We have the input is I0 to In-1, the output is Z. In between we have the select inputs. The select input code determines which input is transmitted to output Z. So these are the functional diagram of 4:1 MUX, 8:1 MUX and 16:1 MUX. In 4:1 MUX we have the 4 input D0 to D3 and the selection lines are S0, S1, the output is Y. Based on the selection line, if the selection line is 0, 0, the D0 is connected to output. If the selection line is 0, 1, the D1 is connected to output. If the selection line is 1, 0, the D2 is connected to output. If the selection line is 1, 1, the D3 is connected to the output. So this is the concept of multiplexer. The multiplexer is not multiply the input, it is data selector. It is select the data based on our requirement. The input is selected based on the selection lines. That's why the multiplexer another name is data selector. For 8:1 multiplexer, we have the 8 inputs, that is D0 to D7. So 2 power 3 is 8. So we have 3 selection lines. The selection line is denoted as ABC. The output is 1. In 16:1 multiplexer, we have 16 inputs, that is D0 to D15. The selection line is 4, ABCD, because 2 power 4 is 16. So 4 selection lines. The output is Y. The 2:1 MUX has 1 selection line and 2 input with 1 output. So this is the truth table and diagram of 2:1 multiplexer. The 4:1 multiplexer has 4 input, 1 output and 2 selection lines or control bits. The 4 inputs are D0, D1, D2, D3. Output is Y. The selection lines are S0, S1. So the output equation is S1 bar, S0 bar, D0 plus S1 bar, S0, D1 plus S1, S0 bar, D2 plus S1, S0, D3. So this is 4:1 multiplexer block diagram, truth table and logic diagram. When the input is, that is selection line is 0, 0, the D0 input is connected to output. When the selection line is 0, 1, the D1 input is connected to output. When the selection line is 1, 0, the D2 is connected to the output. When the selection line is 1, 1, the last input D3 is connected to the output. So based on this, we can get the equation like this. y equal to d naught s0 bar s1 bar, like this. So this is the waveform for 4:1 multiplexer. The first 4 is data inputs, A, B is selection lines, Y is the output data. Next we can consider 8:1 multiplexer. The 8:1 multiplexer, the input is 8, D0 to D7, 3 selection lines, S0, S1, S2, the output is Y. When the input is 0, 0, 0, the first input is connected to the output. When the input is 1, 1, 1, the last input is connected to the output. 8:1 multiplexer logic diagram is shown here. Likewise, we can design 16:1 mux, 32:1 mux, whatever we can design like this. The uses of mux is used in data communication for several computers to communicate over one line, used in radio to select one channel from many, used to route the data within a computer, and used for function generation. The implementation of logic function using multiplexer. The exercise 1 is implement the logic circuit function specified in the table given below by using 8 input data selector or multiplexer. This is one exercise problem. Try it and draw the logic diagram of the multiplexer like we designed the 8:1 multiplexer. Logic function generation using mux method, an efficient method for implementing a Boolean function of n variables with a mux that has n-1 selection inputs and 2 power n-1 data inputs is given below. List the Boolean function in your truth table. Apply the first n-1 variables in the table to the selection inputs to the mux. For each combination of the selection variables, evaluate the output as a function of the last variable. This function can be 0, 1, the variable, or the complement of the variable. Apply these values to the data inputs in the proper order. Implementation of logic function using mux. The solution will be the higher input, the minterms are connected, which is available in the problem, it is connected to the high. This is the another problem with the minterms of 1, 2, 5, 7. Design this function using 8:1 mux or 4:1 mux. Here we have the diagram of 8:1 mux. The 1, 2, 5, 7 minterms are connected to the data inputs are connected to the high. The implementation of logic function using the mux. Next problem is the minterms of same 1, 2, 5, 7. We can round the value of 1, 2, 5, 7 and we can get the values and draw the diagram in 4:1 mux. Likewise, the same problem, implement the function with an 8:1 mux. Select the minterms in the problem 1, 2, 5, 7, 9, 14 and draw it in 8:1 logic diagram. The same problem denoted as a variables. Implement this function using 8:1 mux. Implementation of logic gates using mux. Implement OR gate, AND gate, NOR gate, NAND gate, XOR, XNOR and NOT gate using mux. So here OR gate is implement using 2:1 mux, and the same case for AND gate, NOR gate, NAND, XOR, XNOR and NOT gate. Thank you guys.